Okay, this will be an interesting problem because I actually haven't looked at this yet. I just loaded the image up, so let's solve it with me. I'll solve it with you for the first time and let's see if I do it right. Now, A1 is equal to 250. Let's read the question actually. Ollie pays $250 into a fund at the end of every month for a year. Okay, she does this for 1 year. At the end of every month for a year. Okay. Compound interest of 0.75 is paid per month. Okay. At the end of the year, for a year. Okay, she's only doing this for 1 year. She's only doing this for 12 terms. Okay, nice. At the end of the year, after the last 250 is paid, Holly decides not to invest any more into the fund, but decides not to withdraw the money already invested. Okay, sure. How much is in the account at the end of the year? Now, but decides not to withdraw the money already invested. Okay, how much is at the end? How much is in the account at the end of another year? Oh, okay. So I think until this, we will do our normal what is it? Loan repayments kind of question. No, okay. I think I got the gist of this. Until this, for the first year, right? It's a regular installment question. After that, it's a compound question. So using that amount, we just compound it. I think that's what this question's asking. So I feel like I've got it. Let's go. So first year, reg installments, and then second year, what does he do? It's just compound interest, I think. So let's approach this question then. At A1, right, 250 is paid. After that, she does get the interest of 0.75%, and if you convert that to decimal and add 1 to it, it'll be 0.0075, I think. Okay, and then A2, well, what's A2? At the end of the second month, we're going to continue this up until 12, okay, because that's how many months there are. Yeah, we get this amount, and then Holly pays the thing at the start, so it's going to be a plus 250 times 1.0075, and I think this is the pattern that's going to continue. What's this? 250 times, if you multiply this will become 250 times 1.0075 squared plus 250 times 1.0075, and A3. Remember, you always need to go until the first 3. Okay, it's going to be this amount plus another 250 because you're adding another 250 times the interest. Okay, so then what's that? Well, yeah, you can simplify that. That becomes 250 times 1.0075 cubed plus 250 times 1.0075 squared plus 250 times 1.0075. Easy. Now, that's 0.5 to the 1, just in case you're wondering. Now, what we can do is we can factorize the 250 out, right? And then we'll be listed. And let's factorize it from the backwards because that makes more sense. It'll make more sense in a second. And you see, this is in a GP where we realize that this is a GP as we want to realize that all questions, but the A is equal to what? That's the first term of that GP. Your common ratio is equal to 7.5. And how many terms do you want to go until? Well, you actually want to go until 12 terms, right? You want to go until A12. Okay, leave that. And then once you go into A12, you don't realize this is a GP here, my bad, sorry. Let's keep this to our end, right? Because we've got to show it after the A12. So put the dots, then let's go to A12. A12 is equal to 250. See, we realize that the number here, A3, is corresponding with the highest power here, so we can continue that trend. So copy this, and then dot 1.0075 to the 12. Okay, that is at the 12th term. And yeah, now we can say that this is a GP, yeah, with these following properties. Yeah, and the R is equal to that, and N is equal to 12. Easy. So now what I think we have to do is let's multiply this into, so that's the 250 comes down, and this we can sum it up using our sum of GP. Since this is greater than 1, we can use that 1.0075 times 1.0075 to the n, which is 12 minus 1 over 1.0075 minus 1. Okay, when we do this, we will get a 12, which is equal to, let me just chuck that into my calculator real quick, 1.0075 into 1.0075 to the power 12 minus 1 over 1.0075 minus 1. Okay, having punched that in right, I think, okay, nice. So this amount is going to be 3150.348313. Okay, that's the entire amount. We might as well write it out, dollars. But that is at the end of the first year. So after 1 year, amount is equal to this. That's not a final answer, because that's why you got to read the question properly, I think. Look here, it says, yeah, after that she does not add anything, she does not withdraw anything. How much money is in the account at the end of another year? So at the end of the next year, okay? So to go to the next year, what we've got to do is take this and then compound it, because see how it's compounded, what do you call? We just compound it, because see, yeah, you're putting 250, but it's compounded every month for a year. So now it's just a compound interest formula. We know that our A is equal, this is the formula, right? P 1 plus R to the N, yeah? So our principal will become this new amount. To the power, what's 1 plus R? Well, that's just our interest rate, and our interest rate is going to be 1.0075. And to the n is the number of time period. And what's important is that they're asking for one more year, but then it's in every month. So 12 times, how many months are there in a year? 12. So we can convert it into 12, okay? So this to the power of 12, and that, guys, should give us 1.0075 to the power 12, 3445 times 8, $7 to the 2dp. And our answer is $3420. So yeah, $3420. That is the answer. So see where you went wrong and kind of come back to this. And let's really see if we could, if rounding really made the error. 3150 times 1.0075 to the power 12. Now, rounding did not make the error. So that's all I'm getting. If you found the mistake, do spot it down in the comments. Thank you.